Okay, so this is one-step equations, and first we have some definitions we need to get through. So inverse operation, and this is basically a mathematical operations that are opposites of each other. Okay, so I didn't write them down, but basically this isn't plus or minus. This is adding or subtracting, or addition and subtraction. Also multiplication and division. These are opposites of each other, right? As well as exponents and roots. So if I take a number and I square it, the square root undoes that. So these are also opposites. So these are the mathematical operations that we're used to, and these are opposites. Okay? So equivalent equations are equations that have the same solution. So let's take a look at example 1. We have x plus 5 equals 7 and x equals 2. These are equivalent equations, and I'm going to show you why right now. The way that I create equivalent equations is I use my inverse operations. Okay? In fact, you don't need to use your inverse operations, but if you're trying to solve for a variable, you're going to use your inverse operations. We can create as many equivalent equations as we possibly want just by adding or subtracting or multiplying or dividing both sides the same thing. So what we want to do here, though, is we want to solve for x, because this one is solved for x, right? So I'm going to create an equivalent equation from this one by doing the inverse operation. And what's being done to the variable? It says x plus 5. So since it's being added by 5, what I'm going to do is I'm going to do the inverse operation, which is if it's being added, we're going to subtract, okay? And I usually say the opposite. I don't usually say the inverse operation. Okay, so if we add 5 to both sides, and if you notice, I'm drawing a line down my equal sign. This is just to make sure that I keep my work nice and neat. It's also so that I know that I'm following the one basic, most general rule of algebra, which is if you do something to one side of the equation, you must do it to the other side. Okay, so since I subtract 5 to this side, I must subtract 5 to this side. So here, I get a 0, and sometimes it's helpful to draw that because positive and negatives, those are opposites of each other, right? We get a 0, so all that's left on this side is x. 7 minus 5, these are like terms, so I can subtract them. 7 minus 5 is 2. So as you can see, I went from this equation, x plus 5 equals 7, and by doing an inverse operation, I got an equivalent equation, okay? So this equation is equivalent to this one. And the same here. If I wanted to move from here and get to x plus 5 equals 7, well, what is going on? I need to add 5 to both sides, right? Well, these are not like terms, so I can't add these, so all I have to do is put them next to each other. And I know this seems kind of silly to do this. We're not really solving an equation here, but I'm showing you that as long as you do this one thing to one side and you do the same thing to the other side, you will always get equivalent equations, which is what we want. We always don't want to change the value of the equation, so that way we can solve for our variable and we don't get wrong answers. Okay? So let's take a look at what examples we have here. We have simple one-step equations, nothing too hard, but we do want to make sure we're doing our work correctly. So x minus 11 equals 10. Well, that means what's being done to x? We are subtracting 11. So I'm going to do the opposite. I'm going to add 11. Okay. Again, this is a big 0. Whenever I add or subtract, I want to get a 0. Whenever I multiply or divide, I want to get a 1, okay, in order to clear it out, and I'll show you that later. But there I get x equals, and these are like terms. I add them, I get 21, okay? And what I want you doing is I want you checking your work. So what we're going to do is we're going to plug this number back in to our original equation, okay? So I get 21 minus 11 equals 10. Is that true? 21 minus 11? 21 minus 11 is 10. So as long as I get a true statement here, 10 equals 10, I know that my answer that I found up here is correct. My check is good, so we're good. Okay. So this is when we have subtraction going on. You always want to do the opposite, we add. Here I have division going on. It says x divided by 5 equals 4. So if we're dividing by 5, that means I want to do, again, the opposite of division, which is multiplication. So I'm going to multiply both sides by 5. This becomes a big 1, remember, because I want a 1 in front of my x. X equals 4 times 5 is 20. Okay? And again, check my work. Let's plug it in. 20 over 5 equals 4. 20 divided by 5 is 4. So 4 over 4, my check shows me that x must equal 20. Okay? And we have C. 3 times x, remember whenever there's a number in front of our variable, that means multiplication, okay, equals 12. Well, we can kind of do that in our head, can't we? 3 times some number equals 12. We should know that the answer is 4, but we want to get used to doing the algebra way. And again, the algebra way is, I forgot to do it on B, but you want to draw a line, and we're going to do the opposite of multiplication. We're going to divide. Those cancel each other out, and I get x equals 12 divided by 3 is 4. And we pretty much knew that, right? 3 times 4 equals 12. So just as a real quick check, I will write it, and I want you to write it. Doesn't take that long just to check our work. Okay. So, real quick, I want to show you how to I want you to remember that multiplying by a number's reciprocal will always equal 1. So we learned this a while back, but if I had 3 over 5 and I multiplied it by its reciprocal, which is 5 over 3, I will always get to 1. Okay? So we're going to use that whenever we have a fraction in front of x. So here we have 2 over 3x equals 9. Well, if I multiply by this number's reciprocal, 3 over 2. And again, it's algebra, so I have, whatever I do to one side, I must do to the other. I draw my line. And here, these cancel out, so I'm left with x on this side. And then here I need to do the multiplication. So remember, I can always multiply a whole number by a fraction by turning that whole number into a fraction. So 9 over 1. 9 times 3 is 27. 27 divided by 2, well, that's not going to work, but we can always just leave it as 27 over 2. Okay? B. So again, I have a fraction here. It's a negative fraction, but the same thing works. If I multiply by its reciprocal of 3/4 is 4/3. They're both negative. What I do to one side, I must do to the other. Okay? And let's check this out here. These cancel out. I'm left with x equals negative 12. 12 divided by 3, because I can always turn this into a fraction, right? I can always cross cancel. I can do the division first. 12 divided by 3 is 4. So really I have 4 times negative 4, which is negative 16. Okay? And C, same thing here. I want to multiply by the reciprocal here. So 6 over 5. These cancel. And I have to remember, there's my equal sign. I'm going to multiply everything on this side by that same number, 6 over 5. So here I get x. 12 divided by 5, I can't do that first, so I'm going to have to do the multiplication first. 12 times 6. Well, let's see. 2 times 6 is 12. 6 times 1 is 6, so that's 72 over 5. And the homework, you're probably not going to get crazy fractions like this, but I did want to show you that if you do get a fraction, please leave it as a fraction. If the problem starts with decimals, then give me decimals, but if it has fractions in it, I would hope that you write your answer as a fraction. Okay? So again, on these problems, I would expect you to check your work. These ones are going to be a little rough with the fractions, but we can go over some of that in class.